Hi everyone, and welcome to our latest webinar. My name is Yasen Stoykov, and I'm part of the Ontotext marketing team. The topic of today's session is knowledge management becomes business critical as knowledge graphs improve decision making and efficiency, with speakers Atanas Kyriakov and Joe Hilger. Few words about them. Atanas Kyriakov is the founder and CEO of Ontotext. He's also a member of the board of the Link Data Benchmarking Council, which is a standardization unit whose members include the major graph database vendors. He obtained his master in science degree in AI from the Sofia University in 1995, and today he is a top expert in semantic graph databases, reasoning, knowledge graphs, text mining, semantic tagging, linking, and search. Now, Joe Hilger is a chief operating officer and the co-founder of Enterprise Knowledge, a fast-growing knowledge and information management consultancy based just outside Washington, D.C. He is responsible for the technical strategy, delivery, and partnerships for all of EK. Joe is actively aware of every project that EK consultants work on and helps provide technical direction for the company. Now, before moving forward and giving the word to him, I would like to quickly go over a few organizational details that I think are important. First of all, the session is being recorded, and a link to the recording will be added to a follow-up email. During the presentation, all of you will be muted, and this is mainly to avoid background noises and to let the presenters speak without any interruptions. You can still communicate with us, however, using the question box in your GoToWebinar panel. We strongly encourage you to ask questions in order to have a meaningful discussion at the end, where we have planned a short Q&A session around 10 to 15 minutes. With that, I think we are ready to start the actual presentation. Now I will give the word to Joe, who will begin. Joe?
Thank you, Yasin, and thank you all for attending. Looking forward to talking to you today about knowledge graphs and how they not only align with KM, but how they make KM critical and important in an organization. So we're going to start by explaining how these two concepts fit together, knowledge graphs and KM. Then Naso is going to spend some time talking about the different types of knowledge graph applications that you can build, and it's quite a list and really exciting. Then we're going to talk about Ontotext and their GraphDB platform and how it's one of the most powerful and useful platforms on the market. And then talk about, once you know what these are and some tools to build it, we'll talk about how that gets done and then share some success stories we had. So let's get started. I'm going to talk next about knowledge graphs and KM. So for those that have worked with Enterprise Knowledge or EK in the past, you're familiar with our donut, right? That's the picture on the lower left-hand corner that talks about the life cycle of knowledge management. Everything from creating content through capturing, managing, enhancing, finding, and connecting that content. And so when we talk about knowledge management, we talk about the people, culture, processes, and enabling technologies that help organizations capture, manage, share, and find that information, right? Logical. How are we going to collect this information and make better use of it? As Enterprise Knowledge grew, we stumbled into knowledge graphs, a place that Naso has been for a while. About 3 or 4 years ago, we said, wow, this solves a lot of problems. What knowledge graphs do is they become a tool that helps aggregate that information and put it in a way that offers context and better explanation, so that challenge of enhancing, finding, and connecting with what you need can be solved. So let's dive a little deeper on what this looks like. Right here, as you see, knowledge graphs turn the information you have in all those different siloed applications into knowledge, right? If you look on the right-hand side here, a simple question that one might ask is, what work have we done with a customer ABC in 2019? Well, the answer to that question sits in a lot of places today, right? You want to learn who that customer is, so you go into the CRM system. Then I'll look and see what transactions occurred. So what did we do with them, right? As we see those transactions, I may not even understand what all of that is. So I have to go into some sort of content management system that further explains the products or services potentially that this customer has bought or the work that we've done. And then lastly, we may have had dialogue with that customer and want to know how that went, right? So knowledge graphs allow you to take all these disparate, siloed applications and information systems, pull that information together in a way that models the way you work and think, and get that information back to you in a way that's coordinated well enough that you have, instead of pieces of information, you have a coherent picture or model answering the questions you have. And as I would say, we start to bring back knowledge. So knowledge graphs help really solve, if you go back to our donut, the find and act part of knowledge management, which is a critical part of helping people get their jobs done. Naso, you want to talk a little bit more about this?
Yeah, definitely. So yeah, let me try to explain the concept and introduce you to the different aspects of how knowledge graphs actually do this magic, having this hive chart or whatever. But on the bigger picture, it's all about being able to link together data across different databases or structured systems, be able to also interlink content and data. And what we find really important for many of the applications that we do is also be able to put together proprietary data in global data. So this knowledge graph in the middle, it actually allows many different players to put together data content, and then other players to make sure it is good to use with all the appropriate interfaces. So you have all sorts of data architects and DBAs and operations people who put together data from different sources. You have plenty of people like in publishing houses and other organizations which have serious content management operations who have to deal with the content. And semantic metadata is what actually puts these all these together in a knowledge graph, so that you can more easily find what you're searching for and be able to make to deal with it like a single body of knowledge. So that this metadata is actually the clue that interlinks all these different flavors of information that you have in there. And then once you put it in the knowledge graph, through the years we saw many cases when there is a very strong core team which builds the knowledge graph and does great work to model all sorts of data and take all sorts of considerations, including provenance and whatever is relevant to governance and discovery and so on. And then at some point it becomes too complex. So in many cases we saw in big enterprises the problem that other teams within the same enterprise have hard time to use this knowledge graph, because it became the schema, the structure of this graph, because it incorporates so many different things, becomes relatively complex. So to overcome this, we figured out that there is need for extra work of layering ontologies or semantic business objects on top of this knowledge graph, so that we can define, or the relevant people within the enterprise can define specific views which abstract classes of users from everything that they don't care about. So be it via ontologies or sort of semantic business objects, it is very important to be able to simplify it and make sure that the corresponding groups of users can have the right interface to this knowledge graph. So that's the kind of work One of the things that subject matter experts and business analysts have to do to make sure that the consumption of the knowledge graph is also as straightforward. And then there are always, like, one typical usage is that the whole purpose of putting this data together is to enable further analytics. So to enable some data scientists or some analysts to perform BI tasks and analytics on top of this combined data. So that's why this is the third kind of users of a knowledge graph. So enough about it. We are basically trying to give you the feeling of what's get in and what gets out, how this is consumed, what the actors are, and how it interplays with upstream and downstream systems. To finish off with this story of how knowledge graphs and knowledge management interplay, one thing I spotted recently and realized recently is that knowledge management is underrated. We are Gartner customers. We talk a lot with the analysts there, and when you search knowledge management in Gartner, it turns out that you have very few reports, so they don't pay much attention. And that's about to change soon, because actually doing this knowledge graph involves quite a lot of knowledge management work. That's the work that the same people that do knowledge management and knowledge organization systems do, be it subject matter experts or taxonomies or business analysts or whoever is in charge of these operations within the enterprise. So yes, you have wider set of people playing in there. So system architects and data architects and other data management people, but a lot of the work to make this holistic semantic model is actually knowledge management work. So in a way, you can think of knowledge graphs as the next generation of not so simple knowledge organization systems, which go beyond. I mean, nowadays, if you tell KM to someone, and people most of the time start thinking of, they're going to sell me a controlled vocabulary. That's not a bad thing to do, but it's just part of the story. And in order to build a more holistic semantic data model, you, on top of this, you also have all these furnished with formal semantics using ontologies instead of other type of data schema and models. And then you also have, quite often, typically, you have not only these schema level stuff and then vocabularies, but you also have a lot of master data and reference data incorporated as part of the knowledge graph to enable the interplay of all transactional data and all the content that you put together. And then the last thing is that the entire paradigm and the way in which this knowledge is expressed allows putting together all sorts of metadata that you need to link data across the different systems and to maintain it and to do all the governance. So yeah, Joe, what do you think?
Yeah, I think it's spot on. And a couple important things here, and Nasser, you said this really nicely. Knowledge management early on was a lot about taxonomies and controlled vocabularies, just a way to classify information. And while that was a good start, it didn't solve the core problem of looking at information across a vast number of systems in an easy and usable way. What ontologies do is they take that classification and instead overlay a model that lets you say, these are the entities, these are the people, places, and things that I'm looking at and how they relate to one another. So suddenly, instead of talking about things just as a way of classifying them, we start to say how they relate together, which is the way our mind works, right? When you think of myself, Joe, you say, oh, he's with Enterprise Knowledge, right? When you think of Natsa, you think he's with Ontotext. That's how we relate. So this is a change, but a powerful one. The other thing this has done is, it used to be a lot of knowledge management was just about content and content management systems. because of knowledge graphs and the idea of identifying relationships and pointing to it, data comes into play. And so now we talk about the ability to manage both structured and unstructured data in one place, which has always been, from the early days of knowledge management, one of the holy grails that we were after. So this is a nice thing of the next generation. Back to you.
Well, yeah, it's getting a bigger thing, and I'll try to summarize the different applications and how this knowledge graph paradigm interferes with different types of data management, content management, and other IT services. So at the bigger picture, what knowledge graphs can offer, particularly in as far as data management is concerned, is okay, unified access to data that may or may not be transferred. It could be virtualized or just or transformed, but using this semantic model to give you coherent view of data across different sources. Obviously, having better contracts between everybody in the place, having better metadata descriptions of all data sources and pieces of content allows much more flexible data integration. Knowing more about all the data and the place where it comes from actually allows you to be much more flexible and reactive into how you satisfy specific information needs and so on. And it also allows you to automate data management to a good point. So again, the worst thing here is typically putting together proprietary data, linking together proprietary data, proprietary reference data, if you say the list of your customers with data that comes from the outside would be very, very tough job. And using knowledge graphs, it becomes easier and more feasible to put your proprietary enterprise wisdom together with some knowledge, domain knowledge that you can get from the outside. So, well, in a webinar like this, we can't go away without some Gartner citations. And actually, these people are doing great work in realizing. I mean, in data fabrics, they have a concept called data. Sorry, in data management and data integration, the new thing, the new hype is called data fabric. And at the end of the day, it is just the same thing. It's way more flexible and efficient data integration architecture. And they have realized that the central thing within this architecture is having lots of metadata, rich metadata about the different kind of things that you deal with. And that knowledge graph is the only thing that can deal with so diverse and so much metadata. And also, it is very important that you can deal with it in a way that makes it comprehensible both for people and interpretable for the machines. So essentially, having formal semantics allows you to abstract yourself from, if you want, the syntactic peculiarities of different sources and focus on what you really care about. That's the main message of these people. And speaking of formal semantics and knowledge graphs, well, there is a bit of debate between like, can you do a knowledge graph with property graphs, or RDF is the right way of doing it? I think nowadays there is clear consensus that RDF is much better suited for this job, because there are several features in this technology stack which are particularly good fit for knowledge graphs. So as far as data integration is concerned, the fact that you have global identifiers for everything in the graph is really something that helps interoperability. for formal semantics with all the RDF schema and OW and other standards that are piling on top of it, is the thing that gives you formal semantics and enables reasoning and enables interpretation. The whole thing is, yeah, you have all these abbreviations up there, like RDF or OW Sparkle. They are W3C standards, so they're coming out of a very comprehensive process of standardization across W3C, which makes sure that you have all sorts of players involved. You have the providers, but you have the big enterprises, and then you have some researchers. It takes a while to get there, and it was slow. We are part of W3C and part of this standardization process, yeah, for about 20 years now. But then you end up with something that is much better fit for everybody's needs. And there is nothing like that happening with the property graph space, because, yeah, it essentially Gremlin and related languages, they emerged around the use case of analyzing graphs, say search a path in a graph or something like that. And they're very good for this, but yeah, essentially there is no standardization. It is just starting, and the process is by far not as advanced as the one with W3C. There is no formal semantics, and what sounds scary and is that there is no schema language, so there is no data schema language, so that there is no way in which you can make a formal declarative contract on how your data should look like, which is again part of where it comes from and what the genesis of these different technology stacks are. So if you're a software engineer who wants to put some data together from different sources and run some analytics, then yeah, you don't want to be bothered with schema and semantics and other things. If you're more into putting together a data asset, a knowledge asset that is about to be reused within the enterprise, then I mean, having no schema language is nonsense. So that's essentially the pros and cons of the different standards as far as knowledge graph management is concerned. And as I already spoke, to put this knowledge graph stuff together, you can think of it like everything is metadata. Everything but your transactional data or your scientific data, everything from the data schema to the data catalogs to the taxonomies to reference data is schema, because in a way that's stuff that is auxiliary to the actual data. So it describes it, or describes the usage, or describes something else. But yeah, you can think of it also like the good and the packaging. So the metadata is the packaging of the data, and you know, many cases and many products in which the packaging could be very advanced, and that's for purpose. And the same happens with metadata. So it's quite a lot of stuff with different purposes, all the way from descriptive of what it is in there, to operations logs, which tell you how it is being used, and many other aspects. So now it's good time to basically talk about this fairly heavy, fairly complicated map or graph of all sorts of different applications of knowledge graphs. And historically, many of the early projects that Ontotext did, they were in the space of content management. So it was mostly about we have to analyze some content in order to annotate it and enrich it and do more tagging on it at the end of the day, to enable better recommendation or better search. And that's one of the use cases that Joe will share with you. But that's just one area of applications. If you speak to someone at Gartner, it would be called insight engines. But it interplays very, very closely with the whole spectrum of knowledge management tasks, all the way from vocabulary management, taxonomy management, to more specific tasks like dealing with product information, or dealing with specific configuration and technical knowledge, or skills and competences, or other tasks. So quite often, and as Joe said, the main purpose of having a taxonomy was to be able to better classify your documents so that you can find them. And it's has its roots in the library science. So in many cases, the only purpose of why we do a taxonomy was to be able to do better content management. Then it differs quite a lot of whom you talk to, because for one and the same task like content enrichment, in many enterprises, people will treat it as knowledge management task. If you are more into publishing and media and people who are more content centric, they will consider it content management. The important thing is that these two, over time had a lot of chances to interplay. While usually data management was a completely different discipline, and it doesn't have much in common with content management and knowledge management. Now, knowledge graphs are changing this, because you're using one and the same model, one and the same ontology to put together all these topics and concepts that you typically deal with in terms of taxonomies, with the stuff that you have in your master databases, or reference databases, and so on and so forth. So you see, it's a single paradigm, single technology stack, which has the potential to impact many different applications. In fact, there are plenty of companies which specialize in one of those in order to make a good application for scientific data management, if you want, or for data cataloging. In our case with Ontotext, we are more like in the middle. We do the foundational technology, and partner with many people who do all these applications, and of course partner with people like EK, who deliver solutions on across a few of these areas. So, Joe, do you want to comment something on this map?
Yeah, now, so I've always loved this map, and I, even though it's busy and almost overwhelming, as you look at it, and I want to go through each of these areas. On the top right, we talk about things you can do to improve the management of content, right? How do we make content better managed, better delivered, and actually make it more searchable, right? So knowledge graphs as an infrastructure tool help with that. Then you move to the bottom right, and now all of a sudden we're talking about data. We get calls from people all the time that said, I built a data lake, I put everything together. So I thought it would be easier to find and understand what I had, but guess what? Now I don't know what's there. Metadata and the application of how things tie together really helps with that. CRM and compliance, pulling information together in a way that lets you see what you have and better understand what's there is another key part, right? These are your bots, these are your monitoring tools, and looking at reporting, because again, we can pull stuff from multiple locations. Left-hand side, bottom left, BPM and automation. What I like about this is we had a customer that came to us and said, I don't know where my content is. And it has a workflow, but it moves from system to system. So you can overlay a knowledge graph on top of it and actually solve that workflow issue, because the knowledge graph points to that content as it flows from purpose-built system to purpose-built system. And then lastly, figuring out in the upper left-hand corner, that knowledge management side and what you do with it is critical. How do you find experts? Well, what if you had a tool that didn't just identify the documents someone put together, but possibly information from the HR system about who they are, project information about which projects they worked on? Pulling things together in a knowledge graph makes all of this easier. So the great part about a knowledge graph is you can do all these things with this. The challenging part, and we're going to talk about this soon, is you can do all these things with a knowledge graph. So where do you start? What do you do? how do you present to management what you want here? And we're going to get into some of that as we move forward through this. But Nasa, love this slide. Let's pop into the next part and learn more about Ontotext.
Okay, so a bit of our way of doing things. So a brief note on what is knowledge graph. By the way, yeah, we have our definition on top of when you search in Google, because we've been around for quite a while doing this stuff. So the essence of it is, yeah, putting together the conceptual model, the semantic model, have to so that you have descriptions, proper formal descriptions of all sorts of concepts and entities and relationships that you care about. Then once you put them in a well interconnected graph, they start describing each other. They start providing context to each other. And this helps a lot people and computers to comprehend it and to analyze it and to make sense of it. So in terms of like computer science paradigm, knowledge graphs have at least 3 phases. So you can always look at it like a database, and you can do a structured query. So Sparkle and SQL are not so distinct. So you can just fetch some data out. But you can also look at it like a network, and you can do analytics. And if you have a graph that is big enough, you can run analytics like PageRank, that Google invented 20 years ago to analyze the relationships within the World Wide Web. We are very successful in using the same techniques for analyzing knowledge graphs and figuring out the importance of nodes, for instance, or correlations and other stuff. So that's network analysis. And then the third part of it is that you can treat it like an expert system or knowledge base and do some reasoning and infer some new facts. And you can see like these dashed arrows on the right show you simple pieces of inference, like if you know that the company is located in Seattle, that's part of Washington, that's part of US, be able to infer that, well, this company is inferred in US, sorry, it's located in US. And each of these pieces is relatively simple, but when you have a knowledge graph, think of a knowledge graph of millions of things with billions of such relationships. Then being able to pre-compute this and to do this inference allows you much more easily to find patterns and to find multi-hop relationships that otherwise will be too computationally expensive to search for in real time. And yeah, that's what we do. That's what we believe in. And the other thing is that we've been always working with big knowledge graphs as far as the solutions that Ontotext delivers are concerned, because we believe that computers need to get a bit of, I wouldn't call it intelligence, I would call it awareness. So to be able to properly interpret text or interpret data out of a database, people, when people have to do this, they use a lot of connections and a lot of context that they have in their brains, and it consists of different things. Like it's like we know the differentiating features, as Joe said. When he says I know NASA, he knows that I'm a person and I live somewhere. I have that expertise. I work in this company. And so on and so forth. And so he has a very comprehensive profile of who I am and what I do, and what class of an entity I am, and what the differentiating features are. Eventually, how important I am, and I'm very important. How popular, what are the related concepts, what other things typically co-occur with me in the text, and this kind of stuff. This is something that people know, and that's what we call awareness. So when I say I'm aware of Joe, I mean having these different types of knowledge about it. I'm cognizant of something else. For computer to get this, you need much more. So essentially, you need the kind of knowledge that kids and young people gather in school and then in the university. A critical body of domain knowledge, that gives you this awareness and helps you know things and know how to find this stuff in text and where to read and what to believe in. To do a bit of this for a computer, on our experience, takes essentially modeling billions of facts about as much as 100 million concepts, or for a typical domain, be it business or life sciences, and then also be able to have a system to read really big volume of text about this domain to get used to how these concepts appear in text so that you can better analyze it. So on the bigger picture, providing computers with the right level of intelligence to enable data linking, data interpretation, text analysis requires a lot of domain knowledge, and that's what we've been building these systems for. So you typically start with putting together a knowledge graph, which is usually a combination of some pre-existing master data and vocabularies and stuff from the organization. Then we very often use open data, linked open data, be it DBpedia or GeoNames or Wikidata or some other resource, because that's an amazing source of domain knowledge. In the life sciences, there is an extraordinary volume of databases that are well maintained, well modeled, and with very good identification systems so that you can easily put data together. And in many cases, again, it is not possible to do it just to get this level of domain knowledge and the kind of accuracy that and the richness that is needed. So we have to buy also master data. In the case of companies, it will be master data that you can buy from, I don't know, Dun & Bradstreet or FactSet or Refinitiv or Bureau van Dijk or whoever else. In other businesses, it's something else. So we put this domain knowledge together, then we use it to analyze documents and other content. The result of this analysis is that we generate some metadata, which is stored again in the knowledge graph. And this way you end up with a knowledge graph which has a lot of knowledge about the domain and also very rich descriptions of related content. So this enables a combination of analytical queries and discovery queries, and what people usually do with content becomes really powerful. And for instance, we have built such system for Financial Times, and quite often the end result of this is, well, nothing more, nothing less than a better search or better recommendation system. So if you have ft.com account and you read an article, the suggested reads, the recommended reads that you get underneath the article are generated by such a system, and you don't notice all the knowledge graph underneath. But when they measure the results, it just turns out that recommendation system backed by a knowledge graph works better. And recommendation is one of the cases that we pitched in our previous webinar with Connor from EK. So that's really nice case. So we've been working for like 20 years to figure out how to best make text analysis and knowledge graphs work together. And the basic thing is, well, on one hand, you can use knowledge graphs as a source of known concepts and known entities. So in a typical pipeline, you have something called gazetteer. So you can load this gazetteer with millions of names of concepts and entities to search for. And then this component takes care to look them up in the text and find references. Quite often it is ambiguous. You find Paris in the text, and there could be multiple candidates. Could be Paris in France, or Paris, Texas, or Paris Hilton. So the difference between a good and a bad text analysis system is quite often how good this disambiguation component is. And we use the knowledge graph again because what you have to do is to compare the profile of the document, the context of this reference, with the profile of the entity. And knowledge graphs, well-connected knowledge graphs, rich knowledge graphs with a lot of domain knowledge, give you very good profiles of the entities, and you can do better disambiguation. So that's essentially how it works. And then once you are successful in disambiguating and properly analyzing text, you can extract new stuff from it and enrich the knowledge graph. And then it goes in cycles, pretty much in the way in which people do it. We do have a lot of knowledge in our heads that allows us to read text, and then when we read text, we comprehend this knowledge. That's a cycle, and that's a cycle of knowledge. So technically, the platform combines many different features and different kinds of analytics. Everything that I mentioned so far, from being able to do logical reasoning and infer new facts, to text analysis, to various kinds of graph analytics. So if you want, we have plugins which also provide geospatial reasoning, integration with full text search, and the fancy thing of using like word embedding and graph embedding to derive similarity between concepts, or between concepts and documents, or between documents and documents, and so on and so forth. So the whole point is we essentially spent 20 years to put together a platform which can deal with different kinds of data, which can handle different kind of workloads, because there are transactional systems which deal well with very dynamic use cases and workloads where there are plenty of updates. There are others which deal well with search, and then there are others which deal well with analytics. We know how to combine this, and we have built around GraphDB connectors and integration interfaces that allow us to not only do it in the graph database, but offload as much as necessary to other databases to properly handle the different workloads. So I'm not going to tell you this whole architecture thing. I just want to give you the message that we have thought out of plenty of different ways in which you can access data in the knowledge graph. Be it, if you're a SPARQL fan, you're welcome, but you can do so also via GraphQL, or the drivers which allow front-end developers to do everything they want from JavaScript driver. There is a JDBC driver, so that everyone familiar with SQL or having a SQL integration capability needs to be able to work with it. And of course, in such a system, you need a lot of different tools, so there is no platform that can handle it all. So we have integration with ontology editors, with taxonomy editors, with all sorts of framework to either help you put data in or help you get data out. With this, it's good time for me to hand over to Joe and listen on what's the best way of handle this complexity, because I gave you a lot of opportunities, but quite often people get lost.
Yeah, Naso, thank you. And so, what we've gone through so far is a lot about what a knowledge graph is, and then in more depth what Ontotext brings to the table here with their GraphDB product and solution set. So you can see the power behind this. With power comes challenges, and what we've done in are over 30 different knowledge graph implementations with customers really around the world is we've come up with a repeatable process that works to take the complexity you saw and make it simple. And it's a 5-step process. I'm going to walk you through it now. And really, the important thing to know when you first start is, if you go back to that slide that we talked about, all those opportunities, all those things you can do, right? You're in trouble if you try to do it all. So the first and most important thing is, let's define scope, and let's define a way to be successful, so that when you're talking to your leadership, you can do this the right way. Step 1, define your vision. What are you trying to accomplish? What is the purpose of this knowledge graph? If you leave it as it'll do everything, you're going to have a real hard time getting to real meaning. Within step 1, the next piece of it is, what are those use cases, right? So what's that success that matters? Typically, executives don't invest in something that is, does a lot of great things. That, as an executive, seems scary. They'll invest in something that solves a specific problem. So we regularly work with our customers to say, who've called us and said, I need a knowledge graph. I don't even know what it is. My boss just said I've got to do this, right? we'll talk to them and say, okay, let's engage and let's figure out what are those solutions that matter, that get things started. What are those use cases? And once we have this step one in place, then we can start to move through the next part of the process, right? We've got a vision and a scope of something we can do that matters. Step two is, as you've seen, you have content that could be anywhere, right? You can have now content management systems. You can have your HR and customer relationship management systems. You can actually have databases and data sets, right? So your whole BI initiative could have content for you. And oh, by the way, it doesn't just have to be what's within your four walls. Part of what you can use to create this knowledge graph is content from outside and pulling it all together. So as we look at a use case, step two is, now that I know what I'm going to do, what do I have to work it with? And it's really interesting. We're not even just inventorying what's out there. We're also trying to find out how good it is. And I'll give you a great example of this. A lot of people that we start with say, oh, I want to build a chatbot and I want it to work just like the phone, right? I ask a question, it gives me an answer back. Well, then we start to look at their content stores and everything they have is in a document. Well, if it's in a document, when you ask a question, the chatbot will give you a document back. And maybe that's good enough, but that might not be the use case you planned on. So what we do is we understand, where are you with your content? What's available? How effective will it be towards the use case? There are many times where we pick a use case, we get to step two and say, oh, this isn't really what we want. Let's pick another use case that's a better choice. So this gets the foundation ready, but also as a test point to say, are we doing the right thing? Once we've got our inventory and our knowledge understood, our data, then we can move on and start doing some of the magic, which is the relationship mapping. So in step three, what we're now doing is building that model and creating something that answers the question we defined in the use case. And this is that ontology design. This is, what am I going to do? How does this whole set of information that's all over the place fit together? What are those people, places, and things? And how do they relate to each other? So we start to develop an ontology that doesn't solve everything. It solves the use case in front of you. And the neat thing about that, and the power of these graph databases, are that they're very flexible. So I can start with a small set of answers and then add to it along the way. But this relationship building has to be something that's done in a way that respects, it's not driven by the content, right? Or the information. That's all over the place. What it's driven by is the business need that the user has. So Naso talked about business analysts helping and solving that problem, right? That's what you need, or really knowledge managers, people that get and understand how information fits together and how it should be played together to actually solve a problem. So once we've got the relationships mapped, it's time to move on to step four. And this is where we're very agile in nature, and it matters. We build a solution that solves that use case, but we typically build it for a sliver of the problem or a sliver of the people that are needed, right? So that we can test it. The worst thing you could do is try to launch something in a giant way that's solving some really complex issues and say, oh, this will work, check it out. You run into trouble. So we build a portion of the solution that works for a smaller set of people or for a specific problem within the larger use case. Get that tested, proved out, etc. And once that happens, then we know we've got something. It works, it's solving the user's problems, the ontology we designed is right, the data is right, everything we've put together now works. So step four is done, and now we can move on and start to really grow. So in step five, we take that which we hadn't done and we start to scale it. Instead of building for that small group of users who was our test case, we build for a wider group, right? And instead of using just a portion of the data, we use all of it and we start to bring it in, right? And this is again where one of the reasons we love working with GraphDB is because it scales well. You know, they put a lot of time and thought into scaling, not just for performance on query, but also how do you bring in massive amounts of data and content and automatically tag it and manage it that way, right? So this we start to scale. Once you've complete step 5, you've now got a successful use case. You've got people in the organization that understand the value of knowledge graphs and excitement around it. And then you repeat. Classic agile iterative methodology. Go back to step 1 to build this out. And this is where scaling is so important. Naso, I know you've done a lot with scaling and the challenges here. You want to share some thoughts?
Yeah, well, we've done so much of it that we consider it boring. I'm rather, yeah, I'm more interested to talk a bit on that. This entire methodology is quite knowledge-centric or data-centric, if you want. So it doesn't talk much about software. So what would be the place where, well, the software architecture needed underneath is defined, and how then it evolves. So in your experience, what is the right moment at which you gotta pick your which databases, which search engines, which editors, or which recommendation systems you're getting involved?
Yeah, Naso, that's a great point. So throughout this process of defining the project and managing what the solution we're building, we have to build out the platform. And typically, as soon as we see the vision and use cases, we have an idea. This is the graph database that will work. This is the taxonomy management tool that's needed. And you start to build it out based on that and think through what is that platform. So the platform is built at the same time everything else is. So think of that as a process along the bottom while we're starting to design and build the solution. But you want to start early because this stuff is not easy. And one of the common challenges we run into is often as you're pulling information from other systems, getting through the security and other requirements can be a real kind of slowdown on the process. So being in front of that is important, and getting it done that way. So yeah, you could almost think of this as a parallel process to what we're doing here of building out the solutions, right?
Yeah, that's part of the paradigm shift also, because we had the same experience and we delivered a big number of mission critical systems. So it's not that we are not serious about how the software architecture, but in this kind of projects, it's usually more data driven and knowledge driven rather than software architecture driven, and that's the way it should be. With all the respect of having the software architecture done right, it just has to evolve to handle the information needs, and essentially the whole point of using knowledge graphs is to be much more flexible on what needs you can get handled with the data that you have and the knowledge that you have. So it's natural that with the different applications that you come up in these iteration cycles, the software architecture, the tools that are involved will also change. Okay, do we want to continue with the use cases? That's to me the most interesting part.
Good. So we'll finish at the end with some fun use cases. In respect to our clients, we don't use their names because frankly, they would prefer that we didn't, and it's their stuff and their information. But what we did for them is important, and they're happy for us to share this. In fact, if any of them are on the call, they probably know who we're talking about right now. So the first one is that recommendation engine. And in this case, we were working with a large global development bank, right? And what do? They're funding and supporting projects to help solve problems in other countries. And what they realized is that as someone was talking about maybe building a bridge in Colombia, there was information about building a bridge the right way in Venezuela. And because those countries are in a similar kind of climate, there are some similar problems that they could both learn from. At the same time, when the organization was doing stuff, people could search for stuff, but they often needed it pushed to them. What if you're walking into a meeting and there's some, important news that just came out in Mexico, and you need to be aware of it. So what this organization realized is they needed what they called a semantic hub, what we ended up calling the brain, to help push information to people, not hope that they would search for it, not knowing what was there. So as part of building this brain, we started by building something that pulled in from 12 different data-centric sites, or 12 different content and data solutions, and created the brain, or the central hub of information about it. And the first use case we solved was you could invite the brain to your meeting, and the brain would look at the people in the meeting and both the people in the meeting and the topic of the meeting, and say, here's important information you should know, and it would send it to the meeting host in advance so they could be prepared for it, right? Then as this grew, we developed a chatbot for them, and we also developed something where you could place recommendations, those same recommendations the system was giving elsewhere, in a widget on the website, so all the websites could start to help guide people through stuff. So what did this recommendation engine look like? Well, it looked like this: a bunch of different content sources with an ETL system. In this case, we used Unified Views, which is a product from semantic web company's Pool Party tool. And then the graph database was GraphDB, which we used to manage all of the content and information. And the taxonomy itself was managed using the Pool Party tool. So we could create structure and an ontology design and pull it through. And then we had a semantic hub that was a custom application that pulled information appropriately from the system and then pushed it out to the number of different use cases that were needed. And like I said, we started with 1, and I think we finished with 4 or 5 as we grew. And this is a project that we're still doing cool things with, and we still get, here's our latest, greatest idea. This is success, right? And this is how that worked. So that's the recommendation engine. Next up, this is actually much more data-centric, but a fun problem in and of itself. A very large supply chain organization built a 9 terabyte data lake. And they said, now we've got everything in the same place, we're good to go, right? Well, what they found is all the data sets were there and all the data was there, but no one knew what it was or where it was. And more importantly, what they wanted to do was provide democratization of data. In other words, let managers and executives quickly ask questions and get results back. So what we did in this case is we built a knowledge graph that pointed to the data sets and actually provided context and relation between data elements in the large data warehouse. And what this allowed us to do is then, through this knowledge graph, you could ask a system an English language question, and it would convert that English language question, right, that natural language query, into Sparkle, and from that into SQL, and actually bring back the result set. So where this organization used to have a ton of people in IT that had to quickly build custom reports or custom views or SQL queries, now they had a tool that allowed executives to ask the questions they need and get the answers back that they were looking for quickly and easily. So let's take a quick look at what this looked like from an architectural standpoint. SQL Server and massive amounts of data. It was quite large. The knowledge graph actually did virtual mapping, and what that is it's a concept whereby you actually say, this knowledge graph element points to this data or this data set or this piece of data in the database. And that way, the knowledge graph is modeled to better match your business needs. And if you think about most of your business data warehouses and your BI projects, a lot of those data sets come from transactional systems that are focused on supporting the transaction that they're capturing, not necessarily the question the executive is asking. So by building this graph mapping, we've taken a structure that doesn't work for asking questions, through the graph mapped it to a structure that works, and then built a graph search front end that allowed people to ask these questions. And a fun challenge we had is someone said, okay, here's our question. Who's our #1 customer in our Tennessee plant? And the system figured that out and asked the question. Well, the plant was actually in Knoxville, Tennessee. So then they said, well, what happens if someone says, who's our #1 customer of our Knoxville plant? Well, we said, well, we add a synonym in the taxonomy management system. This flows through and you get the same answer. That's simple. That's managing questions, not building custom queries or having to custom build these answers. So this was a tool that was a powerful way to simplify the complexity of massive data lakes, which I think we all deal with in our organizations. Last up, use case 3, and I know we're coming on time, so I'll go through this quickly. Working with a large research institution, and they were building very complex projects and needed to understand who did what they had, and what expertise exists. So we used a knowledge graph to pull all the documents of their project library, right? And then, as you've seen, as Naso showed you, you can do things like entity extraction. Who are the people that were mentioned in this? What are the projects and topics? And from that, we could create a nice web of contextual information that would allow you to search for not just a term and get a document result back, but a term and get back the people that have worked on a topic for that project. So let's take a quick look at what this looked like from a design standpoint. We had content that was getting automatically tagged. The taxonomy identified what these were, right? This is the basis or the starting point of the ontology. This is a person, this is a place, this is a thing. We could pull that forward. The other thing we could do is we could say, gee, if this person and this project appeared in a lot of documents together, my assumption is this person knew a lot about this project, hence co-occurrence being a way to start to measure some level of knowledge and understanding. So the more content we had, the more power we came up with. Based on this, we were able to create a search, and I can't show you the main one, but I can show you at least a wireframe of what it looks like. So on the next page, you can see that what we have is a search engine that gave you results, but also said, for what this topic you looked for, here are all the people that worked on it, and here's how they map together. So think of that knowledge graph. I'm mapping people to topics, to projects, all through the relationship of the content and how it comes together. Really powerful way to get better understanding of expertise in your organization, what people are doing and how they're doing it. So those are really 3 quick examples of what we've some of the solutions we've built. There's a lot more, as you know, from that early map we shared and posted it. So I think now, I know we're at noon. Naso and I can both stay on a little longer. So if you have any questions, we'd be happy to answer some of those questions now. Yasin, do you want to take over?
Sure, yeah. There are several very interesting questions so far. Feel free to ask any additional if you have. So a question for Naso. How do knowledge graph facilitate matching and ranking of master data?
Okay, ranking is easy because, well, in a knowledge graph, once you can, as I said, you can use network analysis algorithms to score the different nodes in a way in which other databases doesn't facilitate and doesn't allow you to do so. But matching data across different sources, I mean, that's a very tough problem. So you don't have a silver bullet at technology where you throw 1 million entities from one source and 1 million entities from another source and just say, well, please link them. Link those which appear in both sources, like those companies which appear in both databases. So it always requires a little bit of tuning. What knowledge graphs help here is that they allow you to derive and to manage deep semantic, rich semantic profiles of all the entities on both ends. And this is what allows you to do better accuracy pre-selection and then better accuracy automated matching. We had a case where Like in one of our projects, we had to match company data across 5 different databases. So you have on the one hand a source like Standard and Poor's Market Intelligence database, which has like 6 million companies, and you gotta match these companies to those that have also data about them in Crunchbase, which is almost 1 million companies. So this task of matching 5 million things to 1 million things on the other end, it is a very, very challenging record linking project task, and we've been able to get a first working version of it in a matter of month. So just because of having better access to rich information about the entities that appear in the 2 databases. Would you have another question?
Yeah, there is another one for you, and just a second. So how may I present knowledge graph to the C-level management at our organization? I think you can both answer this, but yeah.
I think Joe is like 10 times better qualified than me in addressing this one. So yeah.
Okay.
So which one is it, Yasin, just to make sure I've got it?
Yeah, it's how can a person sell the knowledge management and knowledge graphs to their C-level, their organization.
Yeah, a lot of it gets back to what we talked about. If you walk to your executives and bring the slide that we've got in front of you, they're going to be scared and say, well, what am I getting from this? So the key is to find those specific solutions that make a difference. At that first client we talked about, what they realized is that they had an issue where people didn't know what they needed to know in a timely fashion, and search wasn't going to solve that because search relied on people knowing they had to search for something. So they had specific examples and problems that they were trying to solve. You know, in the second example, we had an organization that said, what I want to accomplish is I need to democratize access to data so that I don't have to go through IT to solve this problem. So, and they said, we need a solution that will solve that. So the best way to pitch this to your executives is to figure out, here's the list of things you can look at. What of these things can be used to solve what specific problem you have, and then say, here's a problem we all know we have. I now have a way to solve it. Let's talk about doing this. And then you can follow up with, and oh, by the way, it can solve some other problems too, but this is the reason you want to start. Hopefully that helps. And we've had a lot of success doing that, and not just doing one project, but after that first win, doing 3, 4, and 5 more because people saw the value.
Yeah. Oh, thank you, Joe. So I suppose it's just a few questions that I can quickly answer. There was a question: what is LOD? Sorry for having a cryptic diagram. That's linked open data. That's publishing data using the RDF standard, and that's the way in which now you have thousands of different data sets published, and this also allows you link data across different data sets, which you can't do otherwise. There was another question asking what is the best description logic level which should be used when we have millions of data links, or how full or how light. I don't think description logic is so relevant to knowledge graphs and most of these applications. So I think that's part of the bad karma of the entire semantic web movement and stack that data description logic guys took over the early standardization efforts of like schema languages like OWL and ontology languages. So the best language the most expressive language that you can use in big systems is called OWL2RL, the RL profile. In most of the projects, you can do quite well with actually even simpler profile. So yeah, something like our light. So, Joe, did you spot the question that you want to get answered?
Yeah, someone asked about the possibility of kind of auto-generating ontologies. And what I would say is typically the ontology is a map of the business needs to the content. And for that reason, if you try to just generate from content what an ontology would look like, that's not going to create a ton of value because you're still not solving the solution of how do I understand what I need. Having said that, where machine learning and automation comes into play is how do I start to tag things at scale in a massive fashion, right? How do I get things classified in the right way so that it fits into my model in a more automated fashion? So I would not encourage people to automatically figure out what my ontology is. That doesn't sound right to me. But once you have an ontology, automate everything you can. Use machine learning to fill it in because you're talking about massive amounts of data and information, and the more you automate it, the better off you are.
Okay, there was another question. Will the presentation be available? Yasin, can you comment on how
Yes, of
people
course.
can? What will be the follow-up with the registered users?
All right, so everyone who is here will receive an email probably on Monday that will include the recording of the presentation, any questions that we haven't answered right now due to time restriction, and also the presentation slides. So this will be included.
Yeah. Okay. There was a question from Anas Taina about Shaco. Yes, we do support data validation via Shaco in GraphDB.
Okay.
Joe, did you spot another question you want to answer?
Another one from Anas. She said, do you provide free consultancy for starter coming from IT relational database background to knowledge graphs? I have a couple thoughts here, and Nazo, you may be able to add to this. The first thing is we have on our website freely, openly available. You don't even have to put your email address in. 40 or 50 different documents explaining these concepts and published on our knowledge graph. So if you go to enterprise-knowledge.com and look at the knowledge base, filter on knowledge graphs, there's a lot of stuff there that can get you started and keep you interested for a while. Beyond that, one of my favorite training, and it's something that our team does all the time, is Semantic Web Company, in addition to their pool party product, has a training, online training. I think you can take 2 to 4 hours of it free to start with. And then that you can purchase a larger training set that is, I think it's 24 hours of training. And I know we have every one of our new consultants that are in this space start with that training as a good way to get a foundation. So those are 2 areas I've done. There's also some good books on this subject. Nazo, how about yourself? How would you get people upscaled on this new technology?
Well, we've been working on this for like 15 years since we realized that yeah, we developed the skills to do stuff, but we gotta help people use it. Well, the best way to go is there is a place called Knowledge Hub on our website, and it's a really rich place with all the way from fundamentals, which are articles like what is RDF or what is knowledge graph or what is Spark or what is semantic web or what is text analysis, everything in very plain language. They're how-to materials with steps. There are blog posts, there are video materials, so you can get a lot of stuff out of it, and we have like tens of thousands of people using it. So you can go there. Beyond that, of course, we do offer training also. Trainings. There are plenty of videos, by the way, on Yasin, what was the name of the channel? There's so many platforms.
We have a YouTube channel where they are available. All of the previous webinars are also available on our website, so you can go see them. There's plenty of material there as well.
Yeah, and okay, I want to answer one more question from Aditya Patil. What if we want to use graph analytics algorithms such as node centrality and PageRank with RDF instead of property graphs in geospatial applications such as digital twin with query models such as GeoSparkle? Well, it's very simple. You just get GraphDB and it does all of this. I mean, we do have a plugin which implements PageRank. It's called RDF Rank because we run it on the RDF graph. And within the Sparkle query, you can just there is a system predicate for this plugin, and you get the rank, and you can sort the results by PageRank or whatever you want. There is a couple of spatial plugins. One of them is GeoSparkle. So it's all in there, and then if that's not enough, you can make your own plugins so that you can implement other graph analytic algorithms. So it's all in there. Yeah, okay, so I think we covered most of the questions. So unless yeah, Joe or Yasin, you want to add something?
No.
Yeah, I feel like we got to everything. Naso, this was fun. Thank you for doing this with me today.
Yeah, thank you, Joe. I gotta admit we didn't practice too much, so we on both hands it was a bit of an improvisation. Sorry that we ran 5 or 10 minutes a bit late with the presentation part of it, and thank you for staying with us and being interested in all the Q&A session.
Thank you very much. Thank you, gentlemen.
Thanks, everyone.
Thank you. Yeah.
Bye.
Thank you, everyone. Bye bye.